Okay, solution stoichiometry. The first thing we need to do is get the reaction into symbols from words. So we know that zinc chloride, zinc being a +2, chlorine -1, is ZnCl2. Reacts with sodium phosphate. Well, sodium's +1, but phosphate is a -3. And when we double replace, we know that zinc is going to bond with the phosphate, and the sodium with the chlorine. And so a couple things I need to do is check out the subscripts. I know that zinc is +2 and phosphate is a -3, so I need 3 zincs and 2 phosphates. But Na and Cl are +1 and -1, so those are fine. Then now to look back at, did I form a precipitate? Well, we're going to find that most phosphates, unless they're with a group 1, are going to be a solid. They're going to be our precipitate. But sodium is an alkali metal. Pretty much those are always soluble in water. So then we need to balance, and so we have 3 zincs on the product side, so we need them on the reactant side. We have 2 phosphates, so then 2 times 3 for our sodiums, 3 times 2 for our chlorine, works out to be a 6 for our sodium chloride. So then, to write the net ionic equation, I'm going to just write that up on the top, is that I just take a look at the solid, and I know that my solid is zinc phosphate. And so where did that come from? And so in a precipitate reaction, it's pretty simple. We just write the ions that make up the solid. So we have 3 zinc +2s and 2 phosphate -3s, and that's going to yield our precipitate. Now, when we look at number 2, then we have a problem to work. And so it tells me, what's really nice about this problem is it went ahead and it gave me moles, just like it did in the test question. So I have 0.8 moles of zinc chloride and 0.5 moles of sodium phosphate. So what I'm going to do is I'm just going to write them up underneath what I'm given. So zinc chloride, I'm kind of going to go ahead and put it on the BCA table. It's already in mole, so I'm golden. So I have 0.8 moles of zinc chloride, and I have 0.5 moles of sodium phosphate. I don't have any moles of the product yet. And so I need to figure out who is my limiting reactant. So the way I'm going to determine that is I'm going to take a look at this 0.8 moles of my zinc chloride, and I'm just going to convert it, and let's do a little conversion factor using the coefficients. I know that for every 2 sodium phosphates, I have 3 zinc chlorides. So when I work this out, I need, the answer comes out to be 0.53 moles of sodium phosphate. So I can see real quick, I don't have 0.53 moles, so I can't use up all of this 0.8. And so it makes my sodium phosphate the limiting reactant. So that's kind of, I'm going to put a little L there. Well, what's nice about that, as soon as you know where your L is that you can create your change line. Your change line is going to be some fraction that's going to be divided by 2. Why 2? It's the number that's in front of the sodium phosphate. And so I know that the change line, I'm just going to put their original numbers on top because it's going to be the fractions. Well, what it's all about is some proportion of sodium phosphate's number, the 0.5. So I'm going to work out the change line's numbers, and if we work this out, we get 0.75, and I can see real quickly that I picked the right guy, because 0.8 is bigger than 0.75, so I know that my excess, my leftover, my afterline is 0.8 minus 0.75, so I have 0.05 moles of zinc chloride left over. This comes out to be the same, 0.5 times 2 over 2, and so that comes out to be none left over. This is 0.25, and so that's going to be my answer, 0.25 moles of zinc phosphate is what's going to be formed. And then the 6 divided by 2 is 1 times 0.5 is 1.5 moles of sodium chloride. So if I look at the question, it asks me to determine the grams of zinc phosphate. Well, I look, I have 0.25 moles of zinc phosphate, so now it's a real simple calculation. 0.25 moles of the zinc phosphate, and I've given you the molar mass, 386.11. So we would just work that out. We have 96.5 grams. So then the last question is, then it's asking me to just look at what is the concentration of sodium that's floating around in this reaction. Well, sodium didn't do anything. Sodium was just a spectator ion. So the amount of sodium you have to start with is going to be the amount of sodium you have to end with. So I know that I started out with 0.5 moles of Na3PO4 floating in 3 liters of solution when it's all done. So if I work this out, how many moles of sodium are there? Well, we got to take into account that 3, because for every 1 mole of Na3PO4, I have 3 sodiums. So I'm just going to say 0.5 moles times 3 moles of my sodium ions. So I'm going to end up with 1.5 moles of sodium. And then I'm going to actually divide that by my 3 liters to get my molarity. So actually, 1.5 divided by 3 kind of cancels out that 3 we multiplied by, so it gets 0.5 molarity of sodium ions. So that's a solution stoichiometry problem.